Hi everyone, welcome to the video on simplifying and solving equations with fractions. We're going to do just a couple examples together, and then at the end of this video I'll have you bring your notes up to a teacher as well as try a practice problem so we can get you some feedback. Okay? Visually speaking, I always like to start with kind of what it is that you're going to be solving. These are the kind of problems we're going to be talking about today. So when most students see these, they usually skip them because they don't like working with fractions. And I would have to agree with you. I like whole numbers better than fractions. So we're going to talk about a strategy to make these kinds of problems so they don't have fractions. Before I teach you the strategy, I like to show you why it works. So at this point, pause the video, please, and put this heading in your notebook. We'll fill in a sentence here and work out an example. All right, now that you've recorded your heading, I just want you to realize that any equation that we work with, I can multiply or divide both sides of the equation by the same number, and the equation stays true. Which sounds kind of like, okay, what are you talking about stays true? Well, here's what I mean. Here's an example that has a true statement. 4 take away 3 is 1. Pretty straightforward, easy to see that in this case, I'll just abbreviate. The left side definitely equals the right side. Okay. Now, what I'm going to do is take the entire equation on both sides times, let's just go 2. We could pick any number. We could have even divided by 2. But just to keep things simple, I'll multiply both sides by 2. 2 times 4, that gives me 8. 2 times a negative 3 gives me a negative 6. And then 1 times 2 gives me 2. Well, 8 take away 6 equals 2. Yep, definitely true. Does the left side still equal the right side? Yes, it does. All right, so this strategy of multiplying and dividing is the one that allows us to simplify equations such as this. All right. When I do the first problem here, you don't have to record it. What I'm going to ask you to record are the 2 strategies I list off to the side, so you have those for your notebook. All right. When we solve problems with fractions, you don't, again, this is just ways to make it easier. This strategy I'm going to teach you essentially just asks you to multiply both sides of the equation by the least common denominator, and I'll abbreviate that LCD. I think most of you are familiar with that abbreviation. Okay, so let's just do that first. And again, if you don't want to write this down, if you just want to watch, go ahead. All right, in this case, the least common denominator is 6. And when we multiply, remember multiplication always occurs on the top of the fraction or in the numerator. So I'm going to multiply this side of the equation by 6, technically 6 over 1. And I'm going to do the same thing over here, times 6 over 1. All right, let's distribute the 6 on the left. So we're going to get 6 times 5/3. And then 6 times negative 1x, this becomes a minus 6 over 1. And actually, I'll put the other one as 6 over 1. 6 over 1 times 1/2 x. I could have put the negative in the parentheses, but then this would have had to have been a plus sign. I generally just like to look at the 2 terms that I'm multiplying and ask myself, is this going to be positive or negative? Well, it's going to be negative here, so I just put the sign out front so it's a lot easier to simplify. All right, and then we end up with 2/3 times 6 over 1. All right, once you get this strategy done, it looks like a big old rotten mess. But you're going to see what happens in just a moment. It's pretty slick. Okay, number 2. Write this in your notes. Simplify. Here we go. On each term, let's just clean up what cancels out and reduce. I noticed the 6 and the 3 reduce. Some students wouldn't even reduce. They would just take 6 times 5 is 30. 1 times 3 is 3. 30 divided by 3 is 10. All right, if you want to reduce it, you can. 6 and 3 reduce. 3 goes into 3 once. 3 goes into 6 twice. 2 times 5 is 10. So either way, it works out. It's just a matter of preference. Okay, minus. We get 6 in the numerator, and when we're multiplying 2 in the denominator, 6 divided by 2 is 3, and then there's still an x on that term. Just bring that down. All right, and that's equal to 2 times 6 is 12. 12 over 3 is 4. And check that out. That looks a heck of a lot easier to simplify. So now I'm going to isolate my variable by doing inverse operation. So I'm going to subtract 10 on both sides. And we're going to get a negative 3x equals negative 6. And if we divide by negative 3 on both sides, I get x equals 2. All right, hopefully you like this strategy. And if you don't, that's okay. I'm not going to require you to use it. I just think it's slick, man. I think if you don't have to deal with fractions, why would you? All right. On this example, we'll use the same strategy. I would record this one just so you have one in your notes. If we look back at our steps, we're supposed to find the least common denominator. So in this case, the least common denominator would be 8. So I could put the 8 here and distribute it. Kind of a shortcut is just to put 8 next to each term in the numerator. And that way it's kind of like the same as distributing. You just don't have to write the first step out. Okay, so let's simplify. 8 times 3, you can put this over 1 if you want. 8 times 3 is 24. 24 divided by 4 is 6. Okay, minus 1 times 8 is 8. 8 divided by 8 is 1. Sorry, my dog likes to make noises. 1x, we'll bring the x down. And then 7 times 8 divided by 4. I don't feel like doing that one mentally, so I'm just going to reduce it first. 4 goes into 4 once. 4 goes into 8 twice. So now I got 7 times 2. That's 14. All right, now we can essentially solve this the same way we've been doing using inverse operation. So I'm going to subtract 6 on both sides. If you want to draw the line down, that's okay. We get negative 1x equals 8. Divide both sides by negative 1. And x is equal to negative 8. All right, at this point, if you have a question, certainly ask it. I'm going to ask when you get done with this question that you bring your notes up as well as this problem, and we'll give you some feedback or some help if you need it. And then you can continue on with the rest of your expectations for the day. Thanks for watching.